Welcome, everyone, to our 40th episode of Canada Talks Electric Cars. Thank you all for joining today as we explore another important aspect of EV ownership. EV Society now boasts more than 2,800 members and affiliates across Canada. Please consider joining our growing EV community to stay informed about this exciting technology and to help others make the transition to clean, sustainable transportation. In today's episode, we're going to learn about tires and some of their unique characteristics that help make our electric vehicles perform to their greatest potential. The Q&A segment of our webinar is always enjoyable, and we welcome everyone to post questions really at any time. If someone else posts a question that interests you, give it a thumbs up to let us know, and we'll do our best to respond in the time that we have available. Today, we are pleased to introduce Russell Shepard, Technical Communications Director at Michelin North America Inc. Russell comes to us with some 20 years of experience with Michelin and 4 years with General Motors. He has a bachelor's degree in mechanical engineering from Florida A&M University and a master's degree in mechanical engineering from Georgia Tech. Russell began his career with Michelin in product research with earth mover and passenger car tires, working in France. During this time, he received 3 patents developing some of Michelin's most innovative tires. After 6 years in France, Russell transitioned to the United States, where he managed tire engineering teams for North America passenger car tires. Russell, thanks for joining us today and welcome to the webinar.
Thanks for having us, Tim, and glad to be here with all of you. It's really a pleasure. There are 2 topics that I'm really passionate about. One is tires, dedicated my career to it, and then there's the emerging topic of electric vehicles. So with that, I will share my screen and start to talk about these 2 topics.
And I'm going to get out of the way and let you have at it. Take
No
care.
problem. So I suppose everybody can see the screen, the full screen. So again, I'm Russell Shepard, and we're going to talk a little bit about tires in electric vehicles and why tire design is particularly important for electric vehicles. It's a really exciting time to be in automotive industry as these new products, this new type of propulsion emerges in electric vehicles, and we're going to talk about it again. One of the things that we've noticed in Michelin as we've monitored the market, and many of you are a part of this, that over the last year, the electric vehicle market has doubled. We also know, looking in the future at some of our customers and partners, that very soon over half of new vehicles will be electric vehicles. That's in the very near future from what we're seeing. So really, there are 2 types of vehicle buyers. There are those that are buying electric vehicles new, and there are those that will sometime in the future buy new electric vehicles because it's coming. You may be aware that there are states like California that are actually requiring that all new vehicles be electric by 2035. So it's a great time to talk about it, and I look forward to having this discussion with you. A little bit about what we're talking about. A few definitions. The kind of standard vehicle is called an internal combustion engine. That's where you put a fuel, typically gasoline, into an engine. It controlled explosion is a nice way of saying combustion, and that produces the energy. You'll hear me and some others refer to this as these ICE vehicles, that's internal combustion engines. The next type of vehicle that you may hear about are hybrid electric vehicles, or hybrid EVs. These are vehicles that have both the combination of an internal combustion engine and an electric engine and a battery system. Some of them you can plug in to charge the battery. Others, they get their power strictly off the braking and regenerative braking. So as you brake, you charge the battery. I think you're aware of this. So those are hybrid electric vehicles. Then kind of the meat of the topic for today, they're battery electric vehicles. These vehicles are fully electric. There's no combustion involved. And they're typically charged by plugging in plus some recharging when braking. Another type of electric vehicle are fuel cell vehicles. This is when you combine hydrogen and oxygen. It generates energy that's converted to electricity, and that runs an electric motor as well. We're not talking about that. So for the purpose of this conversation over the next hour, we're talking about battery electric vehicles and comparing them to internal combustion engines. So let's talk about it. There are really three key factors that are worth talking about when you talk about tires and electric vehicles. One is the impact of electric vehicles on tire life. The other is the impact of tires on the vehicle range, particularly for electric vehicles. Third is road noise. And then as a bonus, we'll discuss a little bit about particularities when driving an electric vehicle in the winter. It's September now, winter's coming, so I think it's a great topic to talk about, uh, uh, especially as it pertains to specifically to electric vehicles. So, a few key facts. Electric vehicles are heavier typically than internal combustion engines. Here you have a chart of a very common electric vehicle and a very common internal combustion engine. The electric vehicle weighs significantly more, over 400 kilograms more than the internal combustion engine, even though that vehicle is really only about 20 centimeters shorter. So it's slightly shorter, we'll call it the same size, but it's quite a bit heavier, 28% heavier. And because it's heavier, all things equal, tires wear faster. It's just simple physics. That additional weight puts additional stress on the tire and the contact patch, and it causes the tire to wear faster. The other thing is that electric vehicles, as we all know, that they use regenerative braking. So on a typical internal combustion engine, whether it's an automatic transmission or a stick, which is more and more rare, there's a period in your driving where you tend to coast. You take your foot off the accelerator and you coast, and then maybe eventually you put your foot on the brake. That coasting period for many electric vehicles is no longer there. It's replaced with the regenerative braking. So you're either driving to accelerate, or you're adding torque to maintain the speed of the vehicle, or you're decelerating. And so overall, there's more torque at higher levels of torque in an electric vehicle between the regenerative braking and the extra weight. You'll often hear discussions about the additional torque at start from electric vehicles. That's true, that's available. But when we've done studies, what we found is consumers typically, after they get over the wow factor, the power of an electric vehicle, they go back to their standard driving habits. And if you don't accelerate any faster in an electric vehicle than you do in an internal combustion engine, you're really not putting any more stress or wear on the tires. So the things that are kind of unique as you go back to steady state and you go to your normal driving is the vehicle is heavier, and then you have more braking torque applied because of the constant um, input for regenerative braking. The result is we've done studies and we found that electric vehicles can wear tires as much as 20% faster than the internal combustion engines. And this is again is because of the weight and the torque. The other part of this that's interesting is typically if you put the same size tire on, the inflation pressure increases. This is because it's not actually the tire that supports the load or the weight of the vehicle, but it's the air pressure. So if you get the same size tire and you want it to support an additional load, you simply put more air pressure in the tire, and that has a little bit of an impact on the wear and a little bit of an impact on noise, which we'll talk about next. So this is pretty simple, but it's worth repeating. The difference between an internal combustion engine and an electric vehicle is you take the engine out, which generates noise, and the exhaust system, which also generates quite a bit of noise. As a matter of fact, the difference in noise across many vehicles is due to the exhaust tuning. So you take that out and you replace it with batteries and motors, and that's the reason the vehicle is heavier, but it also means it's quieter. So the vehicle is quieter, and so you're more likely to notice noise coming from the tires in the road. There are a couple of different technologies that deal with this. One is the acoustic technology by Michelin. It's a polyurethane foam insert. You can kind of see it on here now. Other tire manufacturers have similar technologies. It's designed to attenuate certain types of noise, which we call cavity noise. Okay, so what is cavity noise and when do I hear it? Cavity noise is this resonance that you get in a tire or anything that inflates, that holds air and rolls. It gets to be particularly noticeable when you go across things like surfaces like concrete joints, and you get this boing, boing, boing. Think about it as the noise you make when you inflate a basketball, that kind of bing, that ringing noise. It's also exacerbated when you add more air pressure. So that's one thing to keep in mind. Now here's what we know. This technology works. It reduces that noise significantly. But the trick is, for it to be effective, you actually have to have that noise in your commute. And what we found, studying the market, talking to consumers, and in our own product sales, is that many consumers don't actually encounter the road surfaces or notice that noise. So if you're particularly sensitive to that type of noise, and maybe you've got a particular commute where you've got a lot of concrete joints or bridges with joints that can make that noise, you may find that acoustic technology is useful. There's some manufacturers that have electric vehicle manufacturers that have other solutions besides acoustic technologies, but this is technology is associated quite a bit with electric vehicles. The other feature that Michelin features in its tires to reduce noise is called piano tuning. And this is in all Michelin tires. We've been doing this for decades. And what it does is it reduces the tread pattern noise. You may not know it, but Michelin tires tread patterns have three different sizes. And we use a computer program to optimize those three different sizes of blocks to reduce the noise and attenuate it so that you get lower road noise and it's a quieter ride. Think about it as if you have a piano and you're playing one note and how annoying that can be, or if you play three different notes in a particular order and it's less objectionable and arguably less noticeable. So that's in all Michelin tires. You have the acoustic technology that's primarily for electric vehicles. And we're seeing more and more, not all electric vehicle manufacturers requiring it, but where they do, we offer it. And then you have the piano tuning that is available in all Michelin tires. And that helps reduce pattern noise from the tire. So that's a little bit about the noise. Again, the vehicle is quieter, so you may notice the tire and the road noise. And these are a couple of technologies that help deal with that. So let's talk about the third topic, and that is the impactor range. A little bit of science here. I won't go too deep into it. There are a lot of things that impact the efficiency and range of a vehicle, whether it's an electric vehicle or internal combustion engine. Uh, One of the major differences between electric vehicles and internal combustion engines is the efficiency of the powertrain. For an internal combustion engine, the powertrain is really only about 25% efficient. That means only 25% of the energy generated when the fuel is in the engine gets to the road. For an electric vehicle, it almost flips, and 80% of that power gets to the road. And what that means is that the energy loss due to the vehicle's powertrain is almost all removed. And so the energy loss due to tires, which is called rolling resistance, is actually more noticeable. Okay. So that's a huge difference. You take off all those moving parts that are an internal combustion engine, you simplify things somewhat, and you have a more efficient powertrain, and thus tires become more important. So I hope that's clear. If not, I'll be happy to answer more questions on that later. So, what does all that mean? That means that you will notice the difference in the range of an electric vehicle depending on the tires that you choose, more so than internal combustion engine. And not just that, you may notice a difference in the range between a new tire and a worn tire. The reason why is because roughly 30% of the rolling resistance of a tire comes from the tread. So as you wear down the tread of the tire, you actually improve the rolling resistance of the tire. So in this example, and this is a real world test that we did, we tested a tire. It was an original equipment tire on an electric vehicle. It had a rolling resistance of 7.1 kgs per ton. In this case, lower is better. It had a range in the vehicle, a range about 444 kilometers. When that tire was worn, we buffed the tire down to a worn tread depth. The rolling resistance was reduced to about 5.6 kgs per ton. In this case, it's about a 20% reduction. And the range of the vehicle increased to 463 kilometers. So what this means is you buy a vehicle brand new with new tires, your range could be 444 kilometers. Over 2, maybe 3 years, your tire wears, and you probably don't notice it, but all things equal, you're gaining range, around 4% of range going from a worn tire, from a new tire to a worn tire. You actually gain range as the tire wears. So why am I telling you this in this amount of detail? When you go to replace that tire, you can put that exact same tire back on. And when you drive away with that new tire, it may appear that you've lost 4% of your range. It looks like you've gone from 463 kilometers to 440 kilometers and you lost range. You've actually gone back to your original range, but you've probably forgotten that. And this is a real phenomenon. We've even heard reports of this from hybrid vehicle drivers, where they've gone back to the original tire for replacement and they've quote unquote lost range. And it's in fact because the tire is worn, you got a better range, new tire, increased range. Furthermore, we've done studies and we've mounted about over 20 tires on the market. Some of them are Michelin, some of them are other tire manufacturers. Not going to get into which tire manufacturers there are, but the important thing is on this particular vehicle, on this particular test, depending on the tire you pick, you can lose an additional 17% of range. So then you're going down to 384 kilometers. And for some people, it's not a big deal. For others, that's huge. So it's a couple of things to keep in mind. As your tire wears, your range actually increases slightly by about 4%. And depending on the tire you choose, it can have an impact on the range of your electric vehicle. Whereas for an internal combustion engine, it may be 1 or 2 miles per gallon. Sorry, I'm not converting it to, I'm using the US metrics. Not a significant difference, but there are consumers that may notice differences on electric vehicles. So tires are important for range. It's an important consideration. So you heard me talk for a bit about tires and electric vehicles. I'm going to talk a little bit about winter. All right. Actually, I'm not going to talk. I have a video for you to see.
Hi, I'm Cal Nadeau. Today we're going to do something cool. We're at one of the facilities Michelin uses to test EV vehicles in winter conditions. I think it's going to be interesting. When the temperature falls below 45 degrees Fahrenheit or 7 degrees Celsius, it's time for the winter tires. In all winter conditions, winter tires are engineered to provide better traction than all-season tires. So for me, safety of family is extremely important. That's why I trust Michelin so much. Electric vehicles and hybrid tend to be heavier due to the weight of the batteries. But it's a myth that heavier vehicles provide more traction. Instead, what you get is more momentum. Driving on the same road using the same tires, the heavier car will most often take longer to slow down. This is especially true when driving on wintry road that may be covered in ice and snow. Although there are differences between EVs and non-EVs, the need for winter tires is the same: safety and winter performance. Like internal combustion vehicles, it has been observed that all-season tires typically take longer to stop than winter tires on EVs. Michelin offers many advantages to EV drivers. Driving on high quality, dedicated winter tires like the Michelin XI Snow Tire helps to improve stopping distances. Michelin winter tires offer uncompromised safety and traction on snowy and icy roads. You can rely on your Michelin tires to stay safe.
Ah, don't want to show that again. So this is where I get to the discussion about what is an EV tire. And really, the answer is it depends on what's right for you. Uh, Michelin makes a broad portfolio of tires. And the point of me showing you this is to help you understand that you have some choices you can make. The best tires typically for range and rolling resistance are the tires that for range, excuse me, and noise are the tires that come OE with the vehicle. Those are optimized for range and lower rolling resistance, and they also, if the manufacturer requires it, they'll have the acoustic foam in those. So if you're satisfied with that Michelin original equipment tire and you like that performance, you want to keep that performance, stick with it. However, if there are other things you want to change, like for example, it's winter, and winter, particularly in Canada, I highly recommend, and depending where you are, it's actually required that you mount an ice snow tire, like the X Ice Snow. Keep in mind that a real winter tire not only stops better in the winter, the TG or material properties are designed to have better traction as it gets colder. They're also designed for better performance on ice. There are particular features in winter tires like the X Ice Snow to help you get better traction in ice. They evacuate a little bit of the water on the ice, as well as slush. So as we approach winter, I strongly recommend that you transition over to a winter tire like the XI Snow. What I can tell you about the XI Snow is that the rolling resistance of that tire is not far from OE fitments. And so I would be surprised if you actually noticed a difference in range when you put on a winter tire. So if you're worried about range, don't worry about what the XI Snow. Please go ahead and go for the safety. If you're not satisfied with the wear life of tires, because electric vehicles are heavier, we talked about they can wear tires about 20% faster. There are a few different offers. There is the ultimate wear, we call this Defender family. And what we've done with this tire is we've actually increased the wear life over its predecessor by 20%. Remember, I told you that electric vehicles wear tires 20% faster. So we now have a tire that has 20% greater wear life to compensate for that. It's the same warranty whether you're an EV consumer or not. And so what we're doing is we're giving you the performance that you would normally have in an internal combustion engine in an electric vehicle. The other one is a cross climate family. This is a great option if you don't get a significant amount of ice and snow conditions. Actually, in certain parts of Canada, it's not a bad option. It's Three Peak Mountain Snowflake, so you can use it in the winter, and it gives you great all weather, all year long performance. And that's got a 60,000 mile warranty. And again, when we developed this product, we actually improved the wear over its predecessor. And then there's the Pilot Sport family. There are quite a few electric vehicles that come for the best performance with a summer product. And the Pilot Sport family, including the Pilot Sport All Season 4, gives you all weather protection, all season protection. So really, the question of what is the right tire for your electric vehicle, it's up to you. It is how do you feel about the performance of your vehicle and your current tires? And there are choices that are available where we've taken to electric vehicles into account, and that's why we say our portfolio is EV ready. It's be interesting for you to know, it may be interesting for you to know that Michelin has been making low rolling resistance tires for about 3 decades. We pioneered the use of silica, which is one of the key ingredients in low rolling resistance tires. These tires all have silica in them. And then there are other technologies that we've also added as time's gone along to help balance the compromise of wear and rolling resistance. And so that's part of the story. I've I've talked to quite a few electric vehicle owners, and they've used these products and they've all been very satisfied with them. One last thing about why electric vehicles are so interesting for Michelin, and we're going to talk about sustainability very briefly. So Michelin takes a circular economy approach, and that is when we define sustainability, we look at the raw materials that we use, the manufacturing processes, even the transportation, how these products are used, and the end of life, and we look at all of that and we determine its sustainability. It's called a circular economy approach, and it's part of our goal. So Michelin has a goal of being 100% sustainable by 2050 and 40% sustainable by 2035. There are four key elements to this. There's reduce. So reducing is we're going to reduce the amount of materials that we actually use when we make tires. Reuse, this is where we find other uses for our tires at the end of life, and we'll talk about a little bit about that in a minute. And then recycle is using recycled materials. A great example is we're working to use plastic bottles, which are made of polymers. We're breaking those down to monomers, and we're recycling those materials as reinforcement in tires. And then renewable. How can we use materials that can be renewed? Tires have a great advantage in this, and that one of the key components is natural rubber, which comes from a rubber plant. But we're working to find other sources of materials in our tires to make them renewable. And we define renewable as something that can be regrown, regenerated in the environment within a human lifespan, so about 70 years. So an example is we don't consider sand, which is a major source of silica, as renewable because you really can't renew sand in 70 years. So we're looking for other sources for that, like rice husk. The other thing is we do not want to use materials that interfere with the food supply. So that's why we use rice husk and not rice. It's a byproduct of rice. We also get resins from orange peels, which is a byproduct of orange production. So we don't want to interfere with the food supply and use materials that you would also be considered food. So that's a little bit about our policy. Some things to know along those lines. Michelin recently announced over $300 million of investment in Nova Scotia. We have several manufacturing facilities in Nova Scotia, Canada. And part of that investment was to make our manufacturing facilities and our tires more sustainable. So we're doing things like we're making manufacturing process more energy efficient. We're converting to electric presses, which improves the efficiency of our plant. We're also producing electric vehicle tires in that plant, as well as we're producing in the Nova Scotia facilities truck or commercial tires that are more efficient, lower rolling resistance, thus a more sustainable solution. So that's how all of this fits in. We believe that making low rolling resistance tires is a step in the right direction for electric vehicles and for our overall sustainability goals. And that's about it. So with that, I'll stop sharing and we'll start taking questions.
Awesome. Thanks very much, Russell. I get to look at the questions ahead of time and jump in front of the beginning of the queue to ask two questions quickly, if I could. One is, I'm sure you get this all the time, but what's the future of airless tires?
So as many of you know, Michelin started its airless technology with a product called Twill. And that's now being used on kind of off-road applications, skid steers, lawnmowers, those various applications. We re-engineered, redesigned that for vehicles. That's called Uptus. So again, it's an airless tire. That product is currently in field testing in various parts of the world. We're going to take the time to test it and make sure we get it right, but we're still working on it. We're still very optimistic and we're enthusiastic about that. That is part of our vision for the future.
Yeah.
So stay tuned.
Man, that's awesome. So you genuinely think there's a future for airless tires?
Yes.
Yeah.
Yes, we do.
Oh, terrific. Okay. The other question, just a quick one, and it's probably there is no sound answer to it, but um, as far as quiet tires, noise reduction for winter tires probably doesn't matter as much because of the driving conditions, but you didn't separate on the winter tires range of noise.
So even the winter tires had that Michelin piano tuning. So the blocks are three different sizes, and we use a computer program to optimize the placement of those sizes to reduce the noise.
Okay.
Um, you're right. In winter driving, when you've got slush, the road is covered, you're not going to hear the road surface conditions that are generally going to generate objectionable cavity noise. So that's less of an issue.
Fair enough. Fair enough. All right, Jason. Let's bring Jason Arnaud on. Jason's going to take a look at those questions and filter through and get them out there for you. And again, I'll step aside.
Thank you, Tim, and thank you, Russell. I'll start with an eco-related question. Someone says, I hear that tire detritus washed from roads into the sea can cause negative effects like huge fish die-offs. What's being done to address this sort of environmental issue?
Sure. So about a few years ago, a study was produced that showed that there's a product called 6-ppdq, 6-ppd quinine, that in certain aquatic areas that is harmful to fish. So Michelin and other tire manufacturers have studied that paper. We use 6-ppd to help protect tires as part of the safety protection system of tires, and we've studied that in other works that are published since. It's an industry issue, um, and we're all studying it, trying to understand one what the causes are and what we can do about it overall. So we're working together, collaborating as an industry, both the USTMA in North America and in US, and then even globally to try to understand it.
Okay, some of the changes in formulation that you mentioned when you were talking about sustainability, is that potentially going to help as well?
So with respect to what you're talking about, that product, 6-ppd, has been used for decades and decades and decades. And again, as we consider all the changes that we're making towards sustainability, there are quite a few of them uh, producing synthetic rubber that's not fossil fuel based, but rather from refuse. All of that's included, and we're also, again, as an industry, studying that particular that particular issue.
Okay, great, thank you. Here's hopefully an easy one. Are tires for EV in general more expensive than tires for ICE cars?
Not for Michelin because our tires are compatible for EVs, whether or not they are. The one exception is when you put acoustic foam in the tires. That's just naturally more expensive. So it's a added material. There's a little bit more manufacturing, and it costs more, which is one of the reasons why we are cautious about proliferating the acoustic technology. But other than that, when we design a tire for electric vehicles, it's with the same level of research and technology that we put into all our tires. It's just tuning for different use cases.
Okay, great, thank you. And continuing on the foam question, there's a question about tires with foam. Do they have any benefits as well regarding risk of puncture or risk of air loss?
No, they don't do anything to prevent air loss or punctures.
Okay. And related to that, do you have any research that shows whether the risk of tire puncture is greater for heavy EVs versus ICE cars? Do you see tire failures more often?
So I'm pretty sure we monitor tire returns because it's a great source of data, understanding the performance of tire. I have not heard of any increase in tire punctures because it's an electric vehicle versus an internal combustion engine. I wouldn't be concerned with that.
Okay, thank you. Here's an interesting one. After listening to numerous cars driving by, I have a hypothesis that a treadless tire would be the quietest tire ever. Ignoring for a moment the obvious drawbacks, would this sort of tire be virtually silent?
It would not be completely silent, but you're right. A smooth tire, all of the things equal, same material set, is going to be the quieter tire. But then there's some drawbacks, especially when you talk about winter traction.
Or any traction?
Yes, except for dry traction. It's very good in dry traction now. That's why race cars, when it's not wet, they're smooth. And then when it rains, you start seeing the grooves.
Okay. Here's an interesting one as well. Each new tire is date stamped. How long after the manufacturing date should a tire be installed on a vehicle? Some dealers are selling tires as new when it's 10 months after their manufacturing date.
So what Michelin says is that tires should be removed after 10 years from the manufacturing date. So that is the DOT date. It's the last four digits of the what's called the DOT, which is the week it's manufactured in the year. Okay, so there's 52 weeks, and so number between 1 and 52, and then the last two digits of the year. So that's how you know how old a tire is to the week. If the tire has been on your vehicle longer than 10 years, please replace it. Um, that often happens with RVs where they don't drive long enough. They don't have a lot. You may even have that with winter tires as well. So after 10 years, replace them. Also, after 6 years, we'd like you to get them regularly inspected. Okay. But those are the two recommendations, right? 10 years, remove them, replace them with another set of tires. And after 6 years, get regular inspection of those tires.
Are there matching guidelines for vendors that kind of dictate how long a tire can sit on the shelf before they have to pull it or sell it as used versus new?
No, there are no guidelines. There are certain tire retailers that have their own internal guidelines, and we work with them on that. Quite frankly, our goal is to produce tires that move fast enough to where that's not a big issue. Um, but no, we mainly focus on the 10 years after manufacturing date.
Okay. Why are tires black? Do they need to be black? I suspect I would have more consistent tire pressure if they didn't absorb solar energy as much.
So tires are black because of the reinforcements in them. Natural rubber is not black at all. It's the carbon black reinforcement in them. Um, and another thing. So that's why they're black, and it's part of what gives them the great properties that we all enjoy. But we design them so that even though they're black, they function well, even in the heat.
I assume you're aware of the Goodyear light up tires from the 50s. I assume those aren't coming back.
I'm not aware of those.
No, yeah,
We
they
had
had
some
light up
color
tires.
scorcher tires, so it was different types of the Beer Goodrich had different types of colors in the tread, and of course we still have white raised white letter tires that we that are offered.
Okay, this goes a little back to longevity. Is anyone in the industry looking at tires as a service, or is government looking at regulations that would otherwise encourage tire longevity?
So tires. So there are two things: there's tires as a service or tire longevity. So it's interesting. The airline industry oftentimes they pay for tires numbers of landings, which is more of a service. In the commercial domain, we do offer to manage tires, and that becomes more of a service. And tire longevity, I think what generates the biggest incentive towards tire longevity is all of you. Consumers, especially in North America, appreciate tires that wear longer. We understand that, and that's why we make tires that wear longer. So that, as far as regulations, um, there's nothing in a regulation that's along those lines, but you really don't need to when the consumer demand drives it.
And based on one of your earlier slides, it looks like there's really a spectrum of, do you want more traction? Do you want more lifespan? And you pick your tire
Yes,
based on,
yes.
on what you have. Okay. Uh, does Michelin manufacture run flats for EVs? And if so, which ones?
So we manufacture run flats. We do not manufacture from EVs. And I would not recommend that because vehicles typically need to be designed for run flat tires. The suspension system needs to be designed for that, adjusted for that, or because they're more rigid. The other thing about run flat tires, and I spent several years actually as a tire engineer designing run flat tires, so I know this, the rolling resistance is typically higher. So if you put a run flat tire on an electric vehicle, you will probably notice a difference in the level of comfort, and the range will be impacted.
Okay, great, thank you. Related to that, then, Michelin self-sealing tires come on the Chevy Bolt. Will this technology be expanded across the Michelin lineup?
It's currently available in particular certain applications. As far as expanding it or whatever, I'm not really sure on that. But you're right. We do offer technology called Selfseal. There's even cases where it's Selfseal and acoustic, and that's for punctures in the summit. It actually prevents air loss, not until you can get it serviced.
Okay, here's a question about tire pressure. I've only owned a handful of cars, but notice my EV requires higher tire pressure than my ICE cars, probably because it's heavier. You've mentioned that higher tire pressure contributes to more noise. Is there a solution to allow for lower tire pressure in heavier vehicles, or would that decrease range or have other negative side effects?
So the solution is not for the long-term ultimate solution, and this will happen over time, is to design the vehicle for a larger tire. So there's two ways to have more air. You increase the air pressure, or you make a larger tire. Okay, this is the great example are commercial truck tires that are larger and they have higher air pressure, right? To combine those loads. What I suspect will happen, and I've seen signs of it, is as the next generations of electric vehicles come out, the tires will be larger and they'll drop the air pressure. It also helps with the wear as well. So I think we'll see that evolve.
Okay. Someone asked about using tire sealer in tires that also have acoustic foam. Is that a bad idea?
I'm not going to say it's a bad idea, especially if you need that to get out of a difficult situation.
I'm interpreting the question as this is something that you put in proactively, but
No, I think if so I interpreted it as you have a slow leak or moderate leak, and there's fix a flat is what we call it. You put it in there, and it goes in and it seals the leak until you can get it get to uh, someone who can service the tire and inspect it properly.
next question is, I'm just paraphrasing this, in that there are lots of places that talk about tire wear and tire lifespan. Is there a place or a service that shows tire noise levels so that you can compare them?
There are certain prescriptors that do that. And there's certain websites, tire websites, that they actually test the tires and they characterize the noise. So I hesitate to shout out a name, but there's certain very prominent tire retailers that actually do tire testing, including noise, that can help you determine that.
Okay.
And certain publications as well.
I see Tim just popped on. I have one more. Is it generally better?
Excuse me, one more part.
Yeah.
For Michelin tires, just go to michelinman.com and we rate all our tires relative in noise. So
I'm
that's
going to
easy.
put that. I'm going to put that in the liner notes when the recording goes on our YouTube channel a little bit later. So just I'll make sure I have the right link. I'll check with you and make sure I have the right link. I'll put it up there.
Okay.
Okay, this is a popular question. Is it generally better to go down a size in tire for winter, especially for weight and traction?
No, stick with the size that is recommended by the original equipment manufacturer. It's in the placard. So along the B pillar, you can find the tire size, stick with that size.
Okay, that's interesting because I see it mentioned certainly a lot. So I get the impression a lot of people do it.
I would prefer you stick with the size that the vehicle is designed for. And it also allows you to stick with the pressure, the recommended pressure. There's a whole lot of engineering going on in my head that I won't bore you with if you go to a smaller tire. Just please don't.
And what could I ask? What's the benefit of staggered sizes? So you have I have larger wheels, larger tires on the rear than I do on the front of my car. So I can't rotate them. I don't think in the normal
You can
way.
rotate them this way
You can? Okay.
on the same axle, left, right, or
Yeah.
driver, passenger, yes.
Okay. Okay.
So the benefit of that is you've probably got a rear-wheel drive vehicle.
No, it's all wheel drive, my car.
It's probably all-wheel drive, but it's probably got sometimes more of it's in the rear than in the front, even when it's all-wheel drive. And when you do that, how do I explain this? It's got to do with the cornering power. The larger tire allows you to provide acceleration and corner without losing control. If you because that rear tire has got to do a lot more than the front tire.
Mm-hmm.
It's got to provide propulsion, and it's part of the turning. It's not as much as the front, but it still provides part of the turning. And so you need a bigger tire that's designed to give you great control, max handling.
Thank you. Sorry, Jason. I wanted to get that in there.
Oh, no problem at all, Tim. Here's a question about extra load rated tires, XL rated tires. How important is it to have that rating for EVs?
Oh, that's a good question. I actually didn't put that slide in. So
and how does it affect how tires wear as well?
So extra load tires are pretty common, even for internal combustion engines. More and more, it's very, very common. And what that allows you to do is, as it says, have additional load at additional pressure. So for the same size tire, an extra load tire can handle more load. Electric vehicles have caused the introduction of a new type of extra load tire, which is a high load capacity extra load tire. So at the same pressures, it allows even more load. And these tires are specifically designed for that. You know that because it says HL in front of the size designation, and it still says extra load. So that's become important to allow vehicle manufacturers to develop electric vehicles and put them on the market with the same size tires. Now, when you have a extra load tire, please stick with an extra load tire when you go for your replacement. And if you have a high load HLC, high load capacity extra load tire, stick with that as well.
Thank you. Related to that, do EV tires in general require thicker sidewalls?
No. And in fact, all things equal, thicker the sidewall, the higher the rolling resistance. So, no.
I
Well,
expect it's a constant battle to optimize that.
that's a surprise. I think I've probably said that 50 times to people that the EV tires have heavier sidewalls, and I'm wrong. Thank you.
Okay, here's a trivia question. Do you have any idea how much petroleum is typically used to manufacture a tire?
I do not. It's probably in the annual report and then under the sustainability section. I don't have that memorized, but we take all of that into account when we calculate. We have, like I said, we have sustainability goals at Michelin, and that is part of um, our calculations, and they're pretty complicated. It's like this huge, really complicated Excel file with macros. Anyway, that's part of the calculations that we use to determine sustainability because petroleum products are not renewable. So a great example of that is to make synthetic rubber, you need butadiene. That's a petroleum-based product. What we're doing now is we are studying using biocompost and using that to produce biobutadiene and a few other, and that's what we're using to make synthetic rubber, getting away from the petroleum-based products.
Okay, and now I'm curious, and I'm going to have to look up the annual report and see because I have no idea how much petroleum you need per tire.
And it might not be in there exactly like that. So if I'm wrong or it's not exactly like that, please forgive me.
Oh, no problem.
All right.
Yeah.
Here's an interesting one. Oh, go ahead, Tim.
I was just going to say let's do one more, Jason, and then
One more?
we'll wrap.
Okay, I'll throw in this one then. Does Michelin see a future in developing EV race tires?
Huh. So we pioneered EV racing. So yes. So Formula E was pioneered by Michelin, and that's where we learned quite a bit about making high performance electric vehicle tires. And now we have the Pilot Sport EV, which is for high performance electric vehicles. So I wouldn't say we is future because we're there.
Awesome.
Excellent.
Well,
Thank you very much.
yeah, thank you. Thanks, Jason. As always, you do a great job filtering through those questions for us. That's just wonderful. And Russell, learned a lot here tonight. I really appreciate this. We all do. I know that there are lots of. I mean, I've been spouting incorrect information, and I'll now correct myself. So I really appreciate that, and I'm sure the listeners all enjoyed learning a little bit about tires. We take them for granted, right? And it's literally where the rubber meets the road. So very, very important and helpful information. Thank you so much.
Thank you for the opportunity. Thanks everybody for the questions.
Awesome. All right. Okay, everybody. So on next month's episode of Canada Talks Electric Cars, we're going to be welcoming Christine Derbalis, Senior Director of Public Affairs at Canadian Automobile Association, our great old CAA. Christine is one of the lead spokespersons on CAA's national research on EVs in Canada. So remember to mark that date, Tuesday, October 3rd, always 7:30 Eastern Time. In the meantime, I want you to remember to practice good charging etiquette. When you're using public chargers, just take a moment to check in with the Charge Hub app, adding your comments and maybe a few photos in order to help the next EV owner have a good charging experience. On behalf of the webinar team here at EVS, thanks for joining us for today's episode and for your continued support of the monthly webinar. Our YouTube channel is approaching 1,000 subscribers, which is for us a great landmark. If you're watching us on YouTube or have a moment to visit the channel, please remember to like and subscribe. It helps people find us on YouTube. I'll put a link to our previous webinar episodes on the notes, in the liner notes underneath the recording of this webinar. From all of us at EV Society, until next time, stay well. Thank you, and this will conclude today's webinar.